In Lesson 7.4, we're going to look at elimination using multiplication. You'll learn how to solve systems of equations by using elimination with multiplication and determine the best method for solving systems of equations. How can a manager use a system of equations to plan employee time? The Finneytown Bakery is making peanut butter cookies and loaves of quick bread. The preparation and baking times for each are given in the table below. For these two items, the management has allotted 800 minutes of employee time and 900 minutes of oven time. If C represents the number of batches of cookies and B represents the number of loaves of bread, the following system of equations can be used to determine how many of each to bake. If we take everything in the first equation times -3, we can get our opposites. So now, just like in the last lesson, we add straight down. The b's are going to drop out, so I have -50c equals -1500. And to get c by itself, we're going to divide both sides by -50. And to get b, then, we can substitute back into the first equation. 20 times 30 plus 10b equals 800. So that's going to be 600 plus 10b equals 800. Subtract 600 from both sides of the equation. 10b is 200. If we divide by 10, I get b is 2. And the system of equations should work for both equations, our solution. So I'm going to try and see if we put 30 in for C and 20 in for B in the second equation. 300 plus 600 does in fact equal 900. So I know for a fact my solution is going to be the ordered pair. I normally write in alphabetical order 20, 30. Okay, so again, to get my opposites, I'm going to multiply this first equation times something, and I'm going to pick -2, so that'll make my y's drop out. So we'll have -4x minus 2y equals -46. Then I can add straight down, and I'm going to get -1x. If it makes you happy to put the 1 there, you can. The y's are gone. Equals -9, divide both sides by -1, and x equals 9. When we go back to get our y value, we're going to substitute x back into the first equation. So now I have 18 plus y equals 23. Subtract 18 from both sides, and y is 5. Always a good idea to check in both equations, so I'm going to try and make sure it works. So my x, I said, was 9, and my y was 5. So does 27 plus 10 equal 37? Sure enough. So my answer is 9, 5. Directions are straightforward. Use elimination to solve. But there's no easy thing to multiply this time, that one number is a factor of the other. So I'm just going to multiply the first equation by 5 and the second equation by 3. Hopefully you can see where I picked the 5 and the 3. So I'm going to end up with 15s. So I have 20x plus 15y equals 40, and 9x minus 15y equals -69. And I intentionally got opposites so I could add, because most of the time people prefer adding to subtracting with sign problems. So I have 29x equals -29. So if I divide both sides by 29, I get x is -1. And so when I go back to, we may as well just use the first equation. I'm going to replace x with what I found x equals, which is -1. So now I have negative 4 plus 3y equals 8. Add 4 to both sides. And I get 3y equals 12. I like where this is going. So y is 4. So my ordered pair looks like it is negative 1, 4. Best practice is always a good idea to check by substituting into the other equation. Now I don't expect you to write this down, but I'm showing you what the process is so you can do it on your calculator and your noggin. So in the second equation I have 3 times x minus 5 times y, and I want it to equal negative 23. So did it work? Negative 3 minus 20. Yep. Okay, so I know it works for both equations, so I know that I'm right. Okay, so the big idea for the multiplication method of elimination is you want to multiply one equation by a number or each equation by different numbers so that you can get coefficients that are either the same or opposite. Sames you could subtract, but I chose to do opposites on that example, so we could add, and then we solve just like we did in the last lesson.